events involving not, or, and then we're also looking at odds. So the definitions that we're looking at, we have mutually exclusive if it is impossible for two events to occur simultaneously. So what that means is, let's say that we are drawing a card from the deck of cards. We cannot draw a red card and a black card at the same time. So if you look, we have either red or black, or like the suits, you can't draw a heart, like a 4 of hearts and the spades. You can't draw those at the same time. So those would be mutually exclusive because they cannot occur simultaneously. Same thing if you were to roll a dice. You can't draw like a 1 and a 4 at the same time. So for if it is mutually exclusive, we will use this formula down here. And then if it's not mutually exclusive, we'll use this formula. And then the odds in favor and then the odds against, I'm going to go back to that because this is how the book gives this, but I'm going to rewrite that a different way. So let's go into our exercises. We're going to use this table. It says the table shows the distribution by age of a random sample of 3,000 American moviegoers ages 12 through 74. Use this distribution to find the probability of the following. Alright, so the moviegoer is not in the range of 45 through 64. So we have a total of 3,000. So I'm going to put 3,000 at the bottom. And we want the probability that the moviegoer is not in this 45 to 64 range. So that means that we want them in this one, and this one. So you can do this two ways. You can either add these three up, or you could subtract 3,000 minus 840. Either way, you're going to get the same thing. So remember our probability formula. The probability of an event equals the number of outcomes in that event divided by our total number of outcomes. So in this case, our total number of outcomes is going to be 3,000 in each of these problems. So the easy way to do this one, we could subtract 3,000 minus 840 and we get 2160. So the probability for this specific event, let me erase this. The probability of not being in 45 through 64, there are 2160 out of the 3,000. And that reduces down to 18 over 25. Alright, the next one says that the moviegoer's age is less than 65. So let's come up here, and we have three groups that would be less than 65. Because 65 is right here, 65 to 74. So we're not looking at this group. We want 45 to 64, 25 to 44, 12 to 24. So we're looking at these three groups. So again, you can add all these up or you can subtract and you'll get the same answer. So let me show you. 900 plus 1080 plus 840 is the same as 3,000 minus 180. So if it confuses you and you want to add them up, you can, but if you want to go the shorter route, you can subtract. So So let me show you that they are the same thing. So we have 900 plus 1080 plus 840. We get 2820, and then we are going to subtract the 3000 minus 180, and we get the same thing. So either way, you'll get the same thing. So 2820. So our probability of being less than 65, we have 2,820 out of those 3,000 people, and that reduces to 47 over 50. All right, the last one is the moviegoer's age is at least 25. So this one I want you to think about, and don't confuse yourself. So at least 25. That means that we are looking at moviegoers who are 25 and up. Because if you're 25, you're at least 25. If you're 30, you are at least 25. And so on and so forth. If you're 21, you're not at least 25. So we're looking for 25 and up. So 25 and up would be these bottom three rows. So 25 to 44, 45 to 64, and 65 to 74. So we can add those three up, or we can subtract 3,000 minus 900. So let me write it out. 1,080 plus 840 plus 180, same as 3,000 minus 900 equals 2,100. So the probability of at least 25 equals, we have 2,100 out of those 3,000 people. And that reduces down to 7 over 10. Okay, now we are getting into the OR. So anytime you see OR equals add. So if you look up at your formulas, we are adding those probabilities. So we need to figure out if they're mutually exclusive or not mutually exclusive. Let me change the color. Let's do red. It says a single die is rolled. Find the probability of rolling an even number or a number less than 5. So are these mutually exclusive or not mutually exclusive? So can these events occur at the same time? And yes, you can have an even number and a number less than 5. So these are not mutually exclusive. So we're going to use that formula for not mutually exclusive. The probability of A or B equals the probability of A plus the probability of B, and then subtract probability of A and B. So I'm going to name our first event A and then our second one B. So the probability of even or less than 5, we take our first one, the probability of being even, add it to the second, the probability of being less than 5, and then we subtract both, the probability of even and less than 5. So when we roll a dice, we can get either a 1, a 2, a 3, a 4, a 5, or a 6. So the probability of rolling an even number, we have 2, 4, and 6. So we have 3 out of those 6 numbers that are even. And then we'll add that to the probability of being less than 5. So the numbers that are less than 5 are 4 and down. So we have 4 out of those 6 that are less than 5. And then the probability of being even and less than 5. So out of these 4 numbers that are less than 5, we have 2 and 4 that are even. So we have 2 out of 6. So we are going to add them up. Anytime you add fractions, our denominator stays the same. So we have 6. And then we're going to add 3 plus 4 is 7. 7 minus 2 equals 5/6. So on these, I would suggest leaving these as the like not reduced fraction, so you can add them and subtract them easily. All right, on B, we have an odd number, this is A, or a number less than 4, B. So similar, so the probability of odd or less than 4. Okay, so we'll do the same thing. We'll take the probability of being odd, add it to our probability of being less than 4, and then subtract the probability of odd and less than 4. All right, so let's look at our sample space. We have the numbers 1 through 6. The probability of being odd, we have 1, 3, and 5. So we have 3 out of 6 that are odd. The numbers that are less than 4 are 3 and down. So we've got 3 out of 6 that are less than 4. And then the odd and less than 4, we've got 1 and 3. So we have 2 out of the 6 that are odd and less than 4. So remember, when we add fractions, our denominator stays the same. And we add our numerators, so 3 plus 3 is 6. And then minus 2, we have 4 out of 6. And that reduces down to 2/3. All right, we are looking at a deck of cards now. You are dealt 1 card from a 52 card deck. Find the probability that you are dealt a 7 or a red card. So we're going to have to figure out if it's mutually exclusive or not mutually exclusive. So remember, mutually exclusive, the events cannot occur at the same time. So 7 or a red card. So these can both occur. If we look at our deck of cards, we have 7s that are red. So these are not mutually exclusive. So we'll use that same formula. Okay, so we'll take the probability of 7 or red equals the probability of a 7, add it to the probability of red, and then subtract the probability of 7 and red. So the probability of drawing a 7. So let's look at our deck of cards. I'm only pulling this up because there's a lot of people who don't know what cards are in a deck. So we have 4 7s that are in our deck of cards. So we have 4 out of the total 52 that are 7s. Out of the red, half of our cards are red. So half of 52 is 26. So we have 26 out of our 52 cards that are red. I'm leaving these as the not reduced fractions so that I can add this up easily. If I was to put 1/2, then it would make this more complicated to add, unless you do it in your calculator. But I'm doing it like this. The probability of 7 and reds. So how many of our cards are both 7s and reds? We have 2. So 2 out of 52. So our denominator stays the same. we just worry about our numerator. 4 plus 26 is 30. 30 minus 2 is 28. And then this reduces down to 7 over 13. And if you want to put this in your calculator to reduce it, you could do 28 divided by 52. It's going to give you a decimal, but if you go to math and hover over fraction and hit enter, and then enter again, it'll give you your fraction, your reduced fraction. All right, a heart or a picture or face card. So probability of a heart or a face card. So we will add the probability of being a heart to the probability of the face, and then subtract the probability of a heart and face card. So the probability of drawing a heart. So the hearts are the suits. So we have 13 out of our 52 cards that are hearts. So 13 over 52. We'll add that to the probability of a face card. Our face cards are the jacks, queens, and kings. So we have 12 of those. 12 out of 52. And then out of those face cards, we have 6 of them. We have 3 of them that are hearts. So 3 out of 52 are hearts and face cards. So 52 stays in our denominator. We have 13 plus 12. We've got 25 minus 3, 22 over 52. And then that reduces down to 11 over 26. Okay, now we are looking at odds. So I know that the odds up here, the way that the book tells you to do it is to find the probability of that event occurs divided by the probability that the event does not occur. This is for the odds in favor. So I'm going to write it out a little differently. Okay. So whenever we have in favor, we're going to do it, instead of a fraction, we're going to do it like this. Because the odds aren't, you don't do odds as a fraction. You don't do it as a probability. So it says the odds in favor of drawing a picture or a face card. So we want to find, since we're looking at the favor, we want the number of cards that are face cards. And then over here we want the number of cards that are not face cards. Okay, so let's see. The number of cards that are face cards are 12. Remember, we have 12 out of our 52 cards. So 12 is going to go in our first box. Whenever we find probabilities, we find like 12 out of those 52. In this case, we're going to count the other cards that are not face cards. So 52 minus 12, we have 40 cards that are not face cards. So 12 to 40, but we have to reduce. So if we were to put this as a fraction, like 12 and 40, then we would reduce this down to 3 and 10. So that means our odds are 3 to 10. And you will have boxes cards like this in Pearson. All right, in favor of drawing a black card. Okay, so let me write this out. So we're gonna have our numbers. So this would be the number of cards that are black. And then these would be the cards that are not black. So half of them are black and half of them are red. So we have 26 and 26. So if we were to set it up as a fraction, 26 over 26, that would just be 1 to 1. So our odds are 1 to 1. All right, now we're going to work backwards. We're going to have against. So we just switch the sides whenever it's against. So against drawing a 5. So these are the cards that are not 5s. And these are the cards that are 5s. So we know that there's 4 cards that are 5s. If you look at your deck, we have 4 5s. So that means the rest of them are not 5s. So 52 minus 4 is 48. And so if we reduce this down, 48 over 4, we can do 12 over 1. So our odds would be 12 to 1. All right, the last one, against drawing a red jack. So on the left, we want not a red jack. And then over here, we do want red jack. So if we look at our cards, we have 2 that are red jacks. So that will go over here. So that means that 50 are not. So 50 to 2, this reduces down to 25 and 1. So our odds would be 25 to 1.